In this podcast, we'll use the graph of a polynomial function to help us find the equation. First, we want to figure out what are the x-intercepts and what can we say about the multiplicity of each of those x-intercepts. It touches at -5, so -5 is an x-intercept, and it has to have even multiplicity since it touches there. There's an x-intercept at +1. Again, since it touches, it has to have even multiplicity. And there's a final x-intercept at +3, but since it crosses the x-axis at +3, that should have an odd multiplicity. Putting that together into my equation, I'm looking for the equation with the smallest degree. So I can do that by writing this as x plus 5. That tells me there's an x-intercept at -5. And since it has to have an even multiplicity, the smallest one I can use is squared. There's an x minus 1. Again, it touches, so that multiplicity has to be even. And the x minus 3 factor, that had an odd multiplicity, so I can raise that to just the 1 power, or leave it like that. The last thing to use is the end behavior. Normally this looks like a degree 5 polynomial, but those usually go up to the right and down to the left. So I know this coefficient has to be negative. One way to help me find this coefficient exactly is to use the fact that the graph passes through the point 0, 1. Or in other words, when I plug in 0 into my function, I should get 1. Since there could be any constant out in front, I can think of this as some constant times, 0 plus 5 squared times 0 minus 1 squared times 0 minus 3. When I plug in 0 into my function, I should get out 1. Simplifying, I get my constant times 5 squared, which is 25, times -1 squared, which is +1, times -3, should give me 1. Or in other words, -75 times this constant should give me 1. That says this constant out in front should be negative, again since it has the opposite end behavior, and I can find the value of it exactly, -1/75. When you're writing the equation, we want to make sure that the root and x-intercept behavior matches the picture, and that the end behavior matches what this coefficient should be out in front.